the Hardy-Weinberg principle?
So, hi Miss, I think I could write something. I did write something on Hardy-Weinberg principle just now. So I will explain what I write just now. Oh yeah, this one. So Hardy-Weinberg principle is also known as Hardy-Weinberg equilibrium. It can be said as a state or a law or a theorem, which brings a definition of a allele and genotypic frequency in a population will remain constant from generation to generation. It means that the genotypic frequencies and allele is inherited from parents to daughters and to their grandchildren. So it will be never changed. But this frequency or allele should not be affected by evolutionary influences. If it is affected, then there must be some drastic change or similar small changes in those frequencies and allele. So that's the thing I learned just now. Thank you. Just now in lecture, the doctor was saying something on allele frequency and we do some calculation, right? But I don't understand what is that. So what is allele frequency? Yeah?
So Tanusha, allele frequency, also known as a gene frequency, it is a term used to describe the fraction of gene copies that are of a particular allele in a defined population. So the formula, okay, to calculate the frequency of an allele is a number of copies of a particular allele by number of copies of all allele at the locus. So we can use the Hardy-Weinberg principle, which is the formula is p square plus 2pq plus q square equal to 1. So that is the allele frequency. So guys, what is actually a bottleneck effect and founder effect? Can you explain more to me?
And I will explain more about bottleneck effect and founder effect, but we will be focusing on this paper. Genetic drift is a mechanism of evolution responsible for random changes in gene pool.
Actually, it can be happen to all population. It has drastic effect in small population. It can be driven by chains and non-selection.
Genetic drift can be further divided into two, founder effect and bottleneck effect. Okay, founder effect. For an example, let's take a village with 100 villagers. 95 of them are right-handed and 5 of them are left-handed. And on fine day, 4 of the villagers who are left-handed decided to leave the village and start to grow a new population. This small group lives with varying gene frequency, so the main gene that represent in this new population is left-handed gene, despite it is recessive gene, but it is the only remaining gene.
While for bottleneck effect, we are still in the same village. We have the remaining population is 96 people. 95 of them is right-handed, and one of them is the only one who has left-handed. So imagine that we have a storm hit this population, and it killed 75 from the population, and including the only left-handed person. So the remaining is 21 right-handed person. So this is illustrating of bottleneck effect. Bottleneck effect is the random reduction in population which changes gene pool.
Hanis, what is random mating?
Random mating is a mating of two individuals that are not influenced by its partner's genotype. For instance, we look at the coral polyps, or the male coral polyps will disperse its sperm into the air current, and this sperm in the air current will be in touch with the egg in another coral by chance. So, look at this picture. The parents can choose the same species for reproduction, but the result of the offspring is of random phenotype. So that is about random mating. Thank you.
Okay guys, that's all from us today, and I hope that you understand what we are discussed about. Okay, thank you.